All right, so in 6.6, when we talk about general form of an equation for a linear relation, one of the things we need to do in 6.6 is we need to take a look at a word problem and generate some data, draw a graph, write an equation from that. So this is sort of a big problem, and that's why I want to take kind of the second part of this lesson to do that. Now, generating data for this relation doesn't have to be very complicated or very scary, but when you think about the question, okay, you've got a certain amount of money, or Devin has a certain amount of money to buy peanuts and raisins. Okay, so how many grams of peanuts could he buy, and how many grams of raisins could he buy? There are different combinations, right, that he could spend a full $10 on. So when we generate data, let's draw a data table. Let's do P and R, and I've just got it set up here that peanuts will let be P and raisins be R. So the first thing you might want to consider is, can this person spend all their money on one thing? So could we have just peanuts and 0 raisins, right? And that's going to look like an intercept for a graph, isn't it, if we have one of them being 0? So is it possible? Peanuts are $2 per 100 grams. So if Devin spends all $10 on peanuts, how many groups of $2 are in 10? Or how many grams of peanuts will he have if he just buys peanuts? Any? 500 grams? Okay, is that agreed? Okay. So again, $2 per 100 grams, so you can buy 5 of those. 5 times 100 is 500. Okay, so 500 grams there. Now you don't even have to put the unit if you don't want. We know it's in grams, so just 500. So does everyone see how if Devin spent all of his money on peanuts, he could get 500 grams of peanuts and 0 grams of raisins? We're good? Now, could he spend all his money on raisins and get 0 peanuts? Probably. So $1 per 100 grams. So he can have how many grams of raisins? 1,000. Okay, good. Are you guys good so far? Now, if you have to graph this relation, it's a good idea to have some intercepts, right? This is the y-intercept, or the x-intercept, sorry. This is going to be like the x-intercept on the graph. And this is going to be the y-intercept on the graph. So when you're generating data, it might be a good idea to try those points first. Let's put one other point in there just to make sure we're on the right track. Because if you just have 2 points, they'll always form a line. But if one of them is wrong, you're going to have a completely wrong line. If you do at least 3 points, then if those 3 points line up, chances are you've done all 3 correct. So how could we have a combination? And there are many, right? Okay, what's one other combination? Let's say he buys some peanuts and some raisins. So what's he going to spend on peanuts? How many dollars is he going to spend on peanuts? Just $2? Okay, so he spends $2 on peanuts. That's 100 grams of peanuts. Okay, well, whatever. So how many? If he spends $2, that's gone. How many has he got left? He's got $8 left, and he's going to spend all that on raisins. So how many grams of raisins is he going to be able to get? 800. Okay? And of course there are lots of other points as well. Okay, so that's A. Now B says graph the data. So if we graph this, it's going to look something like, let's just draw a little graph over here. It's not going to be that big. Now we have to look at our scale. So the peanuts, that's going to be, let's make that the x. Okay? So P is the x-axis and R is going to be the y-axis. And peanuts go from kind of 0 to 500 here. So let's do that, 0, and let's make this 500. And so this is going to be about 100 is going to be here, right? 200, 300, 400. Make sure that the spacing is equal, right? The scale is important. Now this one's going to have to go to at least 1,000. So if we make that 1,000, it's going to be about 500 there, and so on. 800 is going to be about there. So let's graph some points. So 500, 0 is one of the points right there. 0, 1,000 is another one of the points. And then we have 100, 800. So does it make sense? Did we do this correctly if we put 100, 800? Does that look like those three are in line? It does, yeah, and this is a linear relation. So if I kind of connect those with a line, let's see how this is going to look here. There we go. That's my line, and I actually don't even, I really shouldn't go into the negatives either, should I? There we go. So we wouldn't need this part of the graph and this part of the graph either. But all right, does that make sense? Are you guys with me there? All right, so that's B now, graphing the data. So if we were to write an equation for the relation in general form, now this is the form that it has to end up in, general form, but you don't have to start in general form. Let's try and, I mean, what form would be easiest to maybe start to write the equation of this line in? Any ideas? Either one of the first two types of equations would be fine. Slope, y-intercept, you could do that. Slope-intercept form. You could also do point-slope form, right? Because you have 2 points, and you can include one of the points. Now the intercept here is pretty easy. That's 1,000, isn't it? So let's do slope-intercept form. That's y equals mx plus b. And what is the intercept? Well, that's easy. That's going to be 1,000, right? Because that's where it hits the y-axis. Okay. How do we solve for x, or the slope? That is the number in front of x. What's the slope? Pick any 2 points. We've got 2 intercepts there. It should be really easy, right? What's the rise? 1,000? Close. How do we make sure we get the right sign on the slope? This is going down, right? So let's make sure we write negative 1,000. I just don't want you guys, because we talked about that at the beginning of class, right? Some of you had problems with getting the wrong signs. So if you go down from the first point on the left, if you have to go down to get to the next point, then write that as a negative. So yes, so positive 1,000 was close, but negative. Okay, so and then this is what? Positive 500, right? So that's negative 1,000 divided by 500, which is negative what? Negative 2? Should be negative 2, right? Okay, so here is our equation in y equals mx plus b form, and the textbook that asks us for a general form. So we learned about general form yesterday. General form is ax plus by plus c equals 0, where a is a whole number, so it cannot be negative. There can be no fractions. B and c have to be integers. And everything has to be on the left side and 0 on the right side. Right? You remember that from yesterday? Okay. So we need to now rearrange this equation into general form. So I'll tell you what, let's get this x term over to the other side. Let's take this positive 1,000 over to the other side and see what happens. Negative 2x, if I bring it over to the other side, becomes positive 2x. If I take a positive 1,000 to the other side of the equation, that becomes a negative 1,000, right? So let's keep this y. Let's write that next. Still positive y. And then we set minus 1,000. Nothing is left over here on the right side, so that's why we put 0 there. Now, I was using x and y, but for this problem, what should we actually be using? Yep, so your final thing would be 2p plus, and this should be r, minus 1,000. equals 0, and that's your answer. Okay, I just kind of defaulted to y and x there. Okay, how are we doing? Questions on that, or are you guys good? So that's C. Now, D, let's just finish this question off. Will Devon spend exactly $10 if, Devon's a she, I didn't know that. If she buys 300 grams of peanuts and 400 grams of raisins. So basically they're asking, is the point 300, 400 on this line? Does it fit with the equation? So you can do it that way. You can graph it and see if it actually is on the line. So 300, 300, and what, 400? Yeesh, I don't know. Could be, maybe, it might be off a little bit here. What's another way you could check it? Well, you could see if 300 and 400 actually fit in the table of values, which means do 300 and 400 actually go into the equation? And that's what I would suggest would be your easiest way of checking. So if you do this, if you plug 300 in for P and 400 in for R, and you put that into the equation, is this statement now true? So that's 2 times 300, that's 600, plus 400 minus 1,000. Well, that's 1,000 minus 1,000. Yeah, that is true. So you see how kind of your graph could maybe fool you a little bit. It's like, oh boy, is that on the line maybe? Well, it appears that this is on the line, right? Which is pretty close to what we drew there. And then of course you could confirm it by plugging it into our equations. That's why equations are handy. You can just plug those things in and it'll be done. So D is yes. And what about 400? Oh, what about the other way around? 400 grams of peanuts, 300 grams of raisins. Well, you could do the exact same thing and test that. 2 times 400 plus 300 minus 1,000. And does that equal 0? And doesn't look like it's going to. That's 800 plus 300 minus 1,000. Does that equal 0? Nope, that's 1,100 minus 1,000. That's going to be 100 on this side. So that does not fit with our equation. All right, so the answer then to this last one, last part would be, it doesn't. Yes and no. And then you would show your work and confirm that. So the last part says use the graph and the equation to justify your answers. So the last thing we just have to do, we did the equation, and this last one, 400, 300. So we go 1, 2, 3, 4, and then 300 would be around here, and I guess it'd just be above the line, so it would not be on the line. Okay?
When you're showing your work, you have to do it like that, or could you just
you have to do it like this. You have to do it like this. Yeah. No, because here, listen, the thing is, here's the equation. You have to show that you're putting the right values into the right parts of the equation. Okay? So I don't want you just to kind of plug it into your calculator and say yes or no.
You wouldn't need to plug it into your calculator, because like for this question, it's just simple.
Well, it is simple math, but you need to show that it's simple math. Like I'm not sure how else you would want to show this work. What else would you do?
Well, couldn't like